Okay.
Hello, Martin. How are you?
Oh, hello, Jean-Noel. I'm fine. I'm fine.
Could you present in a few words the aim of the MOM project, the Memory of Mankind project, please?
The aim of the Memory of Mankind project is to preserve a snapshot of our era for 1 million years in order to give our descendants, the next generations, the next cultures, the next civilizations, an insight into the 21st century. Because, as we know, leaving only digital information will not last very long, and probably the 21st century becomes to a dark century where all information got lost.
Okay, thank you. And how did you come to this idea of the MOM project?
My background is a ceramist. I'm artist with the focus on ceramics, and this is a material which lasts very long. Probably my artifacts will be found in 5,000 years, whereas a washing machine, for example, should break after a couple of years and then in best case gets recycled. And archaeologists in the future will find no physical traces of our era, probably. And knowing the material and knowing some technologies, I thought it would be a good idea to leave some durable data carriers on ceramic basis with text and images as information, which would outlast, I would say, thousands of years, or when it's protected, probably millions of years. And this brought me to the idea to actually do it and find a place to store information kept on ceramic tablets, which is actually the oldest salt mine in the world, not far away where I live. And there, deep inside the mountain, there is the storage of the Memory of Mankind archive, where all the stories from the 21st century, from universities to individuals, from family stories to company profiles, newspaper articles, Wikipedia articles get stored to give an insight into the time and the mindset of the 21st century.
Okay, that's interesting. How do you think that the MOM project could contribute to keeping memory of the radioactive waste repositories around the world?
When I started the project, I was also interested in something which is called in German Atomsemiotik. I mean, I'm interested in any kind of science, not only art and ceramics. And I'm interested in semiotics anyway, so I came up with the idea of atomsemiotics, or the problem which it describes, namely to mark a nuclear waste repository in an understandable way for 100,000 years. And I know there have been some attempts to keep this information or description or warning of a nuclear waste repository, but there is no satisfactory solution so far. And I thought having ceramic as data carrier and keep it in the MOM archive would also help to keep information for a long time, and also the descriptions and the positions of radioactive waste repositories. Rather not as a warning, but as a description and information, because beside the nucleus, it's also a lot of precious material, and future generations should just know where this very precious material is stored.
Okay, and so you are taking part also to other initiatives related to long-term thinking, as I can see. Could you tell us what you are dealing with them?
Yeah, I came in contact with several projects which has the aim of a longer feeling of time, or a awareness that time is nothing which is just happening right in this second, but it's a long thing, far exceeding our personal experience of our personal life. And I think it's some kind of responsibility of any generation, especially our generations, to be more sensible for longer time periods. Concerning nuclear waste, for example, or other toxic waste, which is even more dangerous because it's not cared about as it's cared about nuclear waste, and it has no half-time. But we keep information about the waste we leave, at least as long as the waste is dangerous.
Thank you. And connected to this long-term thinking, you have also ideas for nuclear messages. Could you present them?
The nuclear message, as I came to it, was the idea may be parallel to space messages. When we send messages to space, we must think about the probable intelligence of those who receive this message, and we don't know the recipients, so we have to form this message into a shape where someone with at least a similar understanding, technical understanding of the universe, would understand this nuclear message. And I base this on icons or signs which I think are universal. So there are some signs which could be really universal because they are based on physical laws. For example, or I think a good example is a hammer. I think a hammer will look like very similar throughout the universe. It's always a solid, heavy thing on a stick-like thing, and on the other hand is where you hold it. A hammer, for example, is never made out of a string on the softball. So the depiction of a hammer, for example, would be understandable throughout the universe. And there are others, like the pendulum or waves, or, for example, the table of the chemical elements. Because this is a table which is not arbitrary, it's based on the order of matter. And as long as a society understands the structure of atoms, all the tables will be based on the same principle and will more or less look the same. It was invented twice on Earth, and not by chance. It was because we have the insight into the order of matter, and therefore two different scientists in two different countries realized that there is a regularity behind, and they created these identical tables. I mean, again, one was vertical, the other horizontal, but the basic principle is identical. So the depiction of the elements, the table of elements, and pointing on particular positions would explain, of course, to others who are far away in time or space what elements and what materials we mean. And the table of elements, I think, is a universal sign, so we should use it for communicating about materials.
So, and you, based on these universal phenomena, you think you would be able to build a nuclear what you call a nuclear message, something that describes basic elements about the repository?
Yeah, by depicting the table of elements, there is also the numbers and the atomic weight and the ordering numbers. So by just depicting, using our science and our number system, any future technical society would understand that we have a decimal number system and would very easily understand our numbering system, and therefore we can also describe isotopes, for example, by just, as we have the element with the number, which is clearly understandable, that it's the weight of the atom. And also by some other things, which is, for example, when this message is printed on the ceramic massive plate, for example, we can take this plate as a unit for weight, and then multiplying by numbers gives the amount of material which is stored somewhere deep. And the depth we can define by the measurement also of this table as a unit for length. And there is another thing, which is a phenomenon of ceramic material. A nuclear message printed on a ceramic block with ceramic colors, which are very durable and resistant to acid and UV light or ultraviolet rays. So these colors would stay forever there until they somehow get eroded, for example. But by sand and wind erosion, which would just take quite long, but we have to protect this table somewhere, probably deep in the earth. So this nuclear message would transport the information what is stored in a nuclear waste repository. But what I want to say is ceramic, it has an inbuilt clock, because any silicate containing materials, be it ceramics or rock, has some kind of time indicator based on the phenomenon of thermoluminescence. That means when silicate containing material is hit by cosmic ray, some of the electrons were pushed in a higher level and stay there until the material is heated the next time over 300 degrees, and then they fall down back again and emit a photon. And the longer a material was exposed to the cosmic ray, the more light it emits when you heat it the next time over 300 degrees. This is actually used to determine the age of rock, for example, or the age of ceramic. It's a method to see if some, let's say, Etruscan ceramic is really old, or it's a contemporary fake, because you can't fake this thermoluminescence. And because this nuclear message on a ceramic table is fired at 1200 degrees to be very, very hard and strong, the clock inside the material is then set to 0 and starts to accumulating cosmic ray. And therefore, when scientists in 50,000 years in the future find this tablet and know the phenomenon of thermoluminescence, which, by the way, we know since the 1950s already, can determine that it's an old material, and then find out that it's 50,000 years old. And therefore they can also estimate how much the material, the radioactive material, has decayed, because we indicate the amount and so on. So it has an inbuilt clock. But there are other methods to determine when today is and when we produce this nuclear message. And this uses astronomical phenomena which are happening very, very rarely. And I chose simultaneous transits of Venus and Mercury. That means when the planet Venus is exactly between the Earth and the Sun, we can see a dark spot just traveling slowly across the disk of the Sun. This happens quite regularly, and also with Mercury. What happens very, very seldom is that both planets are visible in front of the solar disk. And the last one was some 335,000 something years ago, and the next one is in the year 96,000 something, and the next but one is in the year 224,000 something. But we can calculate this really exactly on which day in this year it is. So indicating the last one and the next but one, which are three events which are 500,000 years apart, we can indicate where we are now in between this 500,000 years. And also this is a double check for future finders to see the age of this nuclear message, and therefore can calculate how much of the nuclear waste has decayed already, and find decisions whether they want to find this material or not.
Okay, thank you, Martin. And would this ceramic table be also stored in the MOM, or where do you see it?
I would think so, yes. I mean, every repository will have its own nuclear message, because it's explaining what is stored behind there. And I would think that it makes sense to have the copies of all the nuclear messages also in the MOM archive as a redundant information. And if we probably also have on the backside of the nuclear message a hint where the MOM archive is, so then it's some kind of redundancy, which is always good to have some information safely stored.
You are the chairman of the expert group on awareness preservation of repositories under the Nuclear Energy Agency. What is exactly your role as a chairman of this group? And what is the role of this group?
Last year I became chair of the expert group for awareness preservation after repository closure, which means this group focuses on methods on how to find solutions of describing nuclear waste repositories for very long periods. So it stays aware in the people's mind that there is a nuclear waste repository. The obstacle is that we can't define the future, and we can't predict what kind of societies there will be, and if it matters at all that there is a nuclear waste repository. So the struggle is to find solutions for this problem by parallel or simultaneously knowing that it's so hard to predict futures. And therefore this is a real interesting discussion, development of different fields, and as a chair I'm kind of responsible to invite experts and scientists from different fields, not only scientists, but also probably initiatives which are not scientific and has nothing to do with nuclear waste repositories, but also with interaction and engaging people, probably also over long time periods, like time capsules. And combining this, inviting these experts, and finding solutions in very different branches of the society, not only scientific domain, but also in the public domain, whether there are some processes usable for passing on information about the nuclear waste repository. And this goes from being aware that future is hard to predict, to researching for heritage processes in the widest sense, to also semiotics about the signs and icons and how to describe a nuclear waste repository. So it's a quite wide field and very challenging and also interesting. And well, I'm happy to be the chair because it's personally interesting for me. And on the other hand, I feel also happy that nuclear waste industry or the Nuclear Energy Agency selected someone, me as an artist, for example, someone being a chair of a group which is not especially from the nuclear industry or nuclear domain or nuclear entities. And this shows that it's quite open to ideas from outside. And I think it's a good way, because being too focused is probably not the best way to find solutions. I hope this answers your question.
Yes.
Yeah.
Thank you very much.